Okay. Share screen. Are you guys ready for the magic? I hope so. Okay, let me know if you guys can see my screen. Hopefully you can. Cool. Someone's mic is on. Rahel. I'll just mute. Yeah, let's go. Okay, so let's start. So the first question, is this one. Essentially, 32-bit is gonna be 4 GB. I think it was 4 GB, and then it's gonna be the next one is gonna be unlimited. That's what I got for this bit. Next bit, okay, this bit here, it's quite smart. So it's the 192 bit and 50 million, I think it was, because okay, yeah, if I get the diagram up, hold on, if I get the diagram up and I show you guys, one moment. No, usually people, you can't see my quiz, but sorry, one. Why does it not want to hide it from YouTube? Okay, there we go. If we go to that bit. Okay, so you see here how it's between OX, O, okay, let me just put that on the YouTube, and let me hide this. Okay, so, okay, YouTube people, you can see it now. So, sorry as well, YouTube people, if you don't watch these live and you get confused when it goes black. That's just because we have to take precautions. But yeah, so here we find out what that is in decimal. Find out what this is in decimal. And you take them away. Do and then minus them, whatever you get. And then, so one of you guys just tell me what we get if you convert them to decimal, please. Where is blue table? Blue table is usually on it with the with the what's it called? With the calculations. So hurry up, blue table. The pressure's on you. Oh, what F, what F. I think that's it. Looks about right. Take that number, put it in this tab, and then the next number was 04, and then 000. And you get this number. So we're gonna subtract them, and we get this big number here. But remember that it's four bytes. I'm pretty sure this represents 4 bytes, and we only want one. So we'll just divide it by 4, and we get this number, which is about 50 million. So that's why it's the 50 million option. So it's 50 million and about 192. So I think it was I think it was 192 and 50 million. So that seems to be that. Okay, so that's that bit of the quiz done. Okay, and now we on to the tricky stuff. So this one. So this is what we got given, this thing here. So if we just save that as a file .asm, pretty sure I've already saved it. Yep, I've already saved it as week_9.asm. So I'm just gonna open my MIPS, which is the sqtspim, and we got this. Okay, I'm gonna just open reinitialize and load file, and it's just this one. Okay, so what we want to do is we're just gonna take this bit and we're gonna put it into our PowerPoint, trusty PowerPoint. Now I'm gonna enlarge it. Don't really care about the QMU bit. Yeah, so if I just, okay, so essentially we're gonna go backwards and we're gonna take chunks of 2. So we have 51 as the first hex, 4D as the second hex, 55 as the third hex, 4C as the fourth hex. Then we're going to the next line, 21. Then we have double O, oh, double O, double O. Then we have FE, FF, FF again, FF again. And then we have O2, OO, 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 and I'll explain in a second why I'm doing it this way. E5, O7, OO, sorry, and OO again. Okay, because this is little endian, we do fourth bit first. So that's why we do it that way. So essentially we have 51, and this is like the way our hex order is gonna be. Sorry that it's a bit not the neatest. But yeah, that is the way it's gonna be. So yeah, basically that's that. Literally. And then oh yeah, and then as well you wanna write like if it's 8-bit Q, etc. So we have, I think it went QMUL exclamation mark null, and then it was left alignment, then it was fourth -2, fourth, third, sorry, -2 second, -2 first, -2, then it was going to be fourth, 2 third, 2 second, 2 first, 2, and then fourth, 2021, fourth, or third, 2021. 2nd, 2021, 1st, 2021, and legit, that's it. Okay, next question. Well, this is the doubling program. So if we look at this, how does it work? Well, so we're loading the address of where, and we're loading it to this T0 from here. So we're loading the address of this into T0, and then we're going to load the word into T1. And remember, every 4 bytes, 4 bytes, whatever, equals one word. So we want to go to the second word, or second word and double. So we're gonna times it by 4. So 1 times 4 equals 4, which is the address of the second. And then we're just gonna add T1. So we've stored that into T1. So we're going to add 2 T1, T1 and T1. So T1, that just means T1, sorry, equals T1 plus T1. And then store the word back into that place. And this equals a doubler. My handwriting's not it today, I'm so sorry. Next bit. Okay, so we're learning about syscalls. Okay, so basically, if I just paste this link for you guys. Essentially, with this dollar, can you see here? We have this dollar $V0 here. Whatever we store in there, let me just screenshot it and put it in. So whatever we store inside of here becomes a function. For example, when we run the syscall, sorry. For example, let's say we had 4. Let's say in V0 there was 4. Then that when we call a syscall, it actually means function print, and it would just print whatever the next line of code would be. And let's say we wanted to take input, I think that's number 6. So we just put 6 inside of that V0. 6. Yeah, 6 is to just read a number that was inputted. So to read from the console. 6 just means read from that, what's it called? Terminal, what's it called? The little console. Is it called a console? Yeah, the console. That's pretty much that. And yeah, so literally, if we store a different value, so if 6 is stored and we call a syscall, that just means we're reading input, but float input. And what can we do with this? Well, we can actually make pretty cool programs. For example, this one. So let's see. So what does having 4 inside of this do? That means we're just printing. So we're going to print the message on the next line. So this message, we're going to print a message that says, please input a number. And then over here, that's just reading from console. And yeah, so we just keep doing this. And then it's storing whatever we read. Well, typed, sorry, in V0. And over here, we're just adding that value into T0. And then again, we're going to do the same where we're going to message an output. So we're going to output message. So by the way, wherever we see this A0 is what's going to be outputted onto the screen. Wherever we see that A0. But yeah, that's it. Pretty cool, I think. So definitely have like a little mess around with that. You'll find it interesting. And finally, this one is just about jumps. So over here, it's the same kind of idea. It doesn't want to let me write. Sorry. No, there we go. So we're just adding 1 into T0. So we have T0 equals 1. We want to load message 1. And then if T0 is break if equal T0 is 1, is it, well, I mean, sorry, branch if equal. So BEQ equals branch if equal. And what a branch means is we just get a ladder. We take that ladder and we go to this place here. And then we do the same here. Take a ladder, go over here, go over there. And then load address, message 0. And we're gonna do syscall. And then we just exit out as well. So you can just test it out, but that program does work. I feel like I didn't explain that very good, but like legit, you just like whatever you store in that T0 is where your branch is gonna go to. So if let's say this was a 0 in here, then we wouldn't go to this one, we'd go to this one. If let's say it wasn't 1 or 0, it was like 3, we'd go to this one, and we tell the, I don't know, we just go to there and we do a syscall. I don't really know what syscall this would be, but and then we just exit the program. But yeah, that's it. That's pretty much it. Can you imagine? That was kind of short. That's it for you guys on YouTube, but